As we have participants from more than 75 countries, I wish you a good morning, good afternoon, and a good evening. We have reached yesterday around noontime 1,500 registration, and I received many messages from people who were trying to log. But the good news is that you can tell your colleagues, for example, or people who were not able to register for this webinar, that the video will be available just after the webinar will be posted shortly on our website. I am Stéphane Vidry, ILSI Global's Director of Operation, and it is my pleasure to welcome you to the second of a series of 2 webinars on COVID-19 and the importance of nutrition, the immune system. Let's start with my disclosure statement. I am a full-time employee at ILSI Governance and Coordination. I have no financial disclosures regarding ILSI members companies, and I am not providing any consulting services. So maybe a little bit of background, why we thought we, as a scientific organization, had to organize these 2 webinars. Many public health bodies have come up with public health practices important to follow to help reduce the spread of infection. Regular hand washing, avoiding touching the face with unwashed hands, avoiding close contact with sick people, social distancing, and disinfecting frequently touched objects play a critical role in minimizing the spread of illness. At the same time, as a scientific organization working on nutrition, we thought it would be interesting to look how to support the immune system with adequate nutrition as another important and parallel way to help reduce the risk and impact of virus infections. Ensuring adequate nutrition is an effective approach that can support a healthy immune response. Indeed, optimizing nutrient intake as a regular dietary habit is one way to build a more resilient immune system for a longer term. The objective of these 2 webinars are to share the most recent science, help you to understand the role of some of vitamin C, D, E, zinc, selenium, omega-3 microbiome in relation to the immune system and viral infections, but also through some of the questions you've sent already or you will send later to navigate through myth and fake news we hear on TV or read in the press or social media. So in this second webinar, our speaker will address nutrition and antiviral immunity and vitamin D and acute respiratory infections. You can see the topics that were addressed in the previous webinar last week. If you missed it, you can still watch it on the ILSI YouTube channel or in ILSI recent web page. I also put the link here if you have time to take a picture with your phone, in case you don't have time to note. That's another option. And you see, that's one of the beauties of ILSI. We're able to bring to you speakers from Latin America, North America, and Europe. So who more than ILSI knows the value of the dialogue between different stakeholders, public and private sector experts? Therefore, we've made the choice for these 2 webinars to give 25 minutes to each speaker and 30 minutes to you, our audience. We know you have lots of questions. We receive really a lot through your registration form, but you'll have another opportunity today during the webinar to share your question via the chat box. You can see here on the screen how to do that. And I would appreciate if you start your question with the initials of the speakers the question is addressed to, and if you ask short question and concise, so we can try to address more. So just a few words about ILSI, the International Life Science Institute. So we are a non-profit organization whose mission is to provide science that improves human health and well-being and safeguard the environment. ILSI's activity focuses primarily on nutrition and health promotion, food and water safety, risk science and toxicology, and sustainable agriculture and nutrition security. We have many topics, of course, we're addressing, and maybe the latest one are alternative to animal testing, microplastics, food systems, alternative proteins, so big range of topics. As you can see from this map, we have 15 countries or regional ILSI entities across the globe. Altogether, it allows us to address scientific topics from many different perspectives with thousands of world-class scientific leaders. A key feature of the ILSI operating model is that we believe it's vitally important to engage expert scientists from multiple sectors. This multiple sector approach to tackling scientific questions ensures representation of a variety of viewpoints and helps to create robust processes for research, risk assessment, educational activities, and capacity building. This convening of intellectual expertise and pooling of financial resources ensures that only quality, impactful science is pursued. ILSI's mandatory policies expressly forbid lobbying activities of any kind. Rather, ILSI advocates the use of science in making decisions that affects human and environmental health, but it does not make policy recommendation or seek to influence legislative outcomes toward a particular decision. All our governing bodies have a minimum of 50% public sector representation, and transparency is extremely important for ILSI, and therefore the outcome of all our work is published, whatever the result. Scientific integrity is critical to developing sound science for public good. ILSI's policies and model of pooling expert experience and funding helps to manage bias in scientific discovery because no single interest dominates. We know that public-private partnerships are important because diverse perspectives make research stronger. ILSI's multi-sectoral engagement and debate result in more credible science. And ILSI maintains all science should be judged on the merit of study design, methodology, and validity of conclusion regardless of funding source. Also, since the end of 2019, each ILSI entity activity must contribute to the achievement create a positive impact on the United Nations Sustainable Development Goal. We won't have time to dive into our many events, activities, or peer-reviewed publications, 70 last year, for example, but you can find more on our website, looking at our 2019 annual report at ilsi.org, or by visiting the website of our 15 entities. Scientists from academia, government, and industry are working with ILSI because they share the belief that the most meaningful progress is made when multiple sectors of society work together. Many of the most renowned governmental and non-governmental organizations in the world partner with us for the same reason, and we are honored by their commitment. Finally, I want to express my gratitude to ILSI America, in particular Dr. Anya Leon, North America, Europe, and Southeast Asia region, who were strongly involved in the organization of this webinar. Let's now welcome our speakers. The view expressed in the following two presentations and during the panel discussion are solely those of the speakers and do not necessarily represent the views of the International Life Sciences Institute. Each speaker had the total freedom to prepare his presentation. Without further ado, let's turn now to our speakers. First, Professor Philippe Calder. So Professor Calder is Professor of Nutritional Immunology and Health of School at Human Development and Health, the University of Southampton in the UK. He is currently President of ILSI Europe. Professor Calder is an internationally recognized researcher on the metabolism and functionality of fatty acids with an emphasis on the role of omega-3 fatty acids in immunity, inflammation, and cardiometabolic disease. He has also conducted recognized research on amino acid, antioxidant, prebiotics, probiotics, and natural products. His research addresses both life course and translational consideration and include research in cell and animal model and in healthy human and patients. So Philip, I give you the screen. Here you go.
Great, thank you very much, Stefan, and thanks for the kind introduction. So I've got 20 minutes to cover this huge topic of nutrition and antiviral immunity. So I'm going to have a reasonably deep dive into a couple of topics and just mention a few other things along the way that people might be interested in, but maybe will need to find out a little bit more about themselves. So the starting point, I think, are these two really clear statements. The first is that there's nothing that you can eat or take in a supplement that will stop you getting coronavirus. Of course, that's about exposure to the virus. And that's why all of those things about hand washing and social distancing and so on are really important. It's about decreasing the exposure. However, diet, nutrition, and nutritional status are very important in supporting the immune system to combat coronavirus if people are infected. And that's really what I'm going to be focusing on. So what I want to cover is a couple of slides on the immune system and antiviral defense. Then I want to talk about obesity and immunity, specific micronutrients and immunity, and I'm really going to focus on zinc and selenium here because they are super important. Adrian, the next speaker, is going to talk about vitamin D. But of course, many micronutrients, fat and water-soluble vitamins, most of the trace elements are important in supporting the immune system. I then want to say something about the gut microbiome and immunity because that turns out to be very important also. A couple of slides about advice perhaps, and then of course I'll summarize and conclude. So it's self-evident that having an immune system that functions well is key to providing robust defense against pathogenic organisms, bacteria, viruses, and so on. So you need an immune system that's functioning properly to give you the sort of defense that's needed. And we know that's true, of course, because people with impaired immune systems, either because of lifestyle, because of genetics, because of some immune deficiency, have increased susceptibility to infections, both bacterial and viral. For the immune system to be able to deal with the many types of pathogenic organisms that there are, so the many types of bacteria, viruses, fungi, helminths, and so on, the immune system has evolved to be made up of a multitude of different cell types, which is shown on the right-hand side of this chart. So these are all the different cells of the immune system, the B lymphocytes or B cells, which make antibodies, the T lymphocytes or T cells, which have very important controlling functions in the immune response, natural killer cells, then the different types of phagocytes, the monocytes, which can differentiate into macrophages and dendritic cells, and then the neutrophils and so on. These all have their own distinct roles within the immune response, but they all interact together to give a person a full immune capability to defend themselves against whatever might come along. So the different cell types actually have to work together to carry out an effective immune response. And I've captured that here in this figure, which is depicting antiviral immunity, which is our key focus today. So we have on the left a virus, for example, coronavirus, infecting an epithelial cell, as shown in gray here. It turns out that when the epithelial cell is infected with the virally infected cell, some of the viral antigens can be recognized by the host. And there are two immune cells that are particularly important in this recognition. One is this one in red called the cytotoxic T lymphocyte, and the other is the one in orange called a natural killer cell. Both the cytotoxic T lymphocyte and the natural killer cell have the capacity to destroy the virally infected cell. And they do that by releasing proteins that create holes in the membrane of the virally infected cell. These proteins include granzyme and perforin. As part of this process of immune viral infected cell interaction, different types of interferons are released, interferon gamma and the type 1 interferons alpha and beta. These have very important roles in blocking viral replication. So these are really antiviral interferons. We also see interaction of the virus with a dendritic cell or macrophage. This is a classic antigen-presenting cell. And during the course of this interaction, viral antigens are expressed on the surface of the antigen-presenting cell, and they're recognized by different T lymphocytes. Again, the cytotoxic T lymphocyte, but also in green, the T helper lymphocyte. Then I bring the T helper lymphocyte off to the right here. When it is activated through this interaction with the antigen-presenting cell, in the presence of certain cytokines, it differentiates into a T helper 1 cell. That produces cytokines like interferon gamma, which can create antibody production from B lymphocytes. So plasma cells are antibody-producing factories derived from B lymphocytes. Those antibodies are specific to the viral antigens. They can coat the virus and therefore neutralize the virus. So we see lots of interactions here between the virally infected cell, the antigen-presenting cell, the T cell, and the B cell to bring about effective antiviral immunity. Now, the immune response itself, so the different cellular components, for example, is affected by many, many different exposures. So, for example, people's genetics can affect the immune response, illnesses, medications, being physically fit, smoking, alcohol consumption, stress, all of these things impact the immune response one way or another. Today, I'm going to talk about 3 factors that can influence the immune response: nutrient intake or diet, the gut microbiome, and obesity. And of course, they're all related to one another because obesity is related to nutrient intake and the gut microbiome is related to both nutrient intake and obesity. So let's start with obesity and this observation, which is in Press in Obesity from French, in the journal Obesity from French researchers, looking at ventilation requirement in patients with COVID-19 admitted to the ICU. So what you see in the graph at the bottom are the different BMI ranges from normal weight in green up to BMI greater than 35 in red. And the outcome here is requirement of mechanical ventilation. In other words, significant lung injury as a result of COVID-19. And what the researchers show is the requirement for ventilation increases with BMI, so that those people with the greatest BMI in the study had about twice the need for ventilation for ventilation support compared to those with a normal BMI. So there's something about obesity which predisposes to more severe COVID-19. Now that might be about lung function in obese people, but it might also be about the immune system in obese people. Now, it turns out quite a lot's known about obesity and the immune system. And in fact, most cell responses are impaired in obese people compared to normal weight people. For example, T lymphocytes, cytotoxic T lymphocytes, B lymphocytes, and natural killer cells, those 4 key cell types dealing with antiviral immunity, are all impaired in obese people. Antibody responses are impaired, and production of interferon gamma is impaired. We know that obese people are more susceptible to many infections, and they don't respond so well to vaccinations. In fact, in the 2009 H1N1 influenza pandemic, it was noticed that obese people had slowed antiviral responses and weak antiviral responses. And if they were infected, they had poor recovery from disease. Obese people have prolonged period of flu virus shedding. In other words, they don't deal with the flu virus so quickly. And that prolonged incubation of the flu virus actually allows the emergence of more virulent minor strains in obese people. It's also interesting that obese people vaccinated with the seasonal flu vaccine still have twice the risk of getting flu compared to normal weight people, indicating that they have poor protection from vaccination. The other thing is that obesity is a state of chronic low-grade inflammation, and that might also predispose to more severe disease. This is an interesting study in which cells were taken from healthy, overweight, and obese people and then incubated in a test tube with the seasonal flu vaccine. And the outcomes here are production of activated cytotoxic T lymphocytes, production of granzyme-expressing cytotoxic T lymphocytes. And remember, granzyme is one of these proteins that creates holes in virally infected cells, killing them, and interferon gamma-producing cytotoxic T lymphocytes. And what the researchers found was that all of those outcomes were reduced by about 50 to 60% if the cells came from obese people compared to healthy weight, with overweight people being somewhere in between. So what this says is cytotoxic T cell activation and function is impaired in obese people compared to normal weight. The researchers showed a similar thing in another study where rather than using the seasonal influenza vaccine, they actually used the H1N1 influenza virus. And again, they showed that cells from overweight and obese people didn't respond as well as cells from normal weight. So obesity certainly impairs antiviral defenses. Let's move on now to consider micronutrients and immunity. So first of all, when a person is infected, they have a big increase in demand for energy and for nutrients. Those nutrients will be things like building blocks, like amino acids to make immunoglobulins, receptors, and so on. Regulators of the molecular and cellular aspects of the immune response, so nutrients like zinc and vitamin A are important there. Substrates for synthesizing chemicals involved in the immune response. Some nutrients like zinc have specific anti-infection roles. I'll come on to that later. And then because the immune response is a battle between the host and the pathogen, the host needs to be protected against the damaging effects of their own immune response. And here the antioxidant vitamins, cysteine, and some trace elements are very important. So if you consider all of this, it's quite clear that an appropriate nutrient supply, giving appropriate nutrient status, will give you appropriate immune function. In other words, getting the nutrition right makes sure the immune system can work properly. And the outcome of that will, of course, be better defense against pathogens. If you turn that round the other way, inadequate nutrient supply will impair the immune system, so you have impaired defense against pathogens, more infections, more severe infections, illness, and death. This has been well described many times. For example, in this paper looking at elderly Ecuadorians, where micronutrient deficiencies were linked to both impaired immune responses and increased burden of respiratory infections. Many micronutrients were important here, but particularly zinc. So observational studies and experimental studies in animals and in humans have identified a whole range of nutrients which are really important to support the immune response. So all 4 fat-soluble vitamins, A, D, E, and K, many water-soluble vitamins, including most of the B vitamins and vitamin C, trace elements, zinc, copper, selenium, and iron, several amino acids, including cysteine, glutamine, arginine, essential fatty acids, long-chain omega-3 fatty acids, and also other constituents of plant foods like polyphenolics have been shown to improve aspects of the immune response in humans. If you want a good overview of the micronutrients, the vitamins and minerals in the immune system, this is a recent review that's quite comprehensive in covering these, and I recommend this paper to you from Nutrients earlier this year by Gombart and colleagues. So, of course, I don't have time to talk about the myriad of micronutrients, so I've just picked 2, zinc and selenium, because I think they're particularly interesting and important. So first of all, zinc deficiency is known to impair many aspects of the immune response, T cell function, B cell function, balances within the immune system, and so on. It's important to note, of course, that zinc excess is also immunosuppressive. So there's a spot in the middle of adequate, appropriate zinc status where the immune system is supported properly. The role of zinc in the human immune response has been known for decades now. And these are older papers, one from 1981 and one from 2016, which report the effects of zinc supplementation on the immune response in older people. Both of these trials showed that supplemental zinc for a period of months increased different aspects of the immune response over that time period. The Barnett study at the bottom here used 30 milligrams of zinc a day for 3 months in over 65-year-olds who had low zinc status to start with, and they showed improvements in T cell function in that study. I mentioned before, the correlate of improved immune function would be decreased illness, and this is mortality from severe pneumonia in individuals given zinc supplements as part of the treatment for pneumonia. And what the meta-analysis shows is a reduction of around about 50% in mortality in individuals with pneumonia given zinc compared to those not given zinc. In the context of coronavirus infection, it's interesting that zinc is an inhibitor of a particularly important enzyme, and that's this enzyme on the left here called RNA-dependent RNA polymerase. So coronaviruses are single-stranded RNA viruses. That's their genetic material. And once they infect host cells, of course, they have to replicate. So they have to copy this single-stranded RNA. And that's where this enzyme, RNA-dependent RNA polymerase, is important. That enzyme is important in terms of making more copies of the viral RNA, but also in making the copy of the viral RNA that ultimately is translated into viral protein. Turns out that zinc is a good inhibitor of RNA-dependent RNA polymerase. And that means zinc can interfere with viral replication because it stops the virus from making its more RNA and viral protein. So that's interesting. And 10 years ago, researchers reported that in cell culture, zinc could inhibit replication of coronavirus. So this is a study where epithelial cells were infected with coronavirus in a laboratory, and then those cells were incubated either with no zinc or increasing concentrations of zinc. And this shows the RNA products, the 9 RNA products that are produced by the virus. So in the absence of zinc, those RNA products are all produced, but as zinc concentration increases, so the ability to produce the viral RNAs is decreased. I think that's an interesting observation. So just last year, there was a whole review on the role of zinc in antiviral immunity, and I recommend that paper to you by Reed in Advances of Nutrition to read more about the many roles of zinc in antiviral immunity. Let me move on to selenium now. So again, selenium plays important roles in supporting T cells, B cells, and antigen-presenting cells, and selenium deficiency impairs many aspects of the immune response, making people more susceptible to both bacterial and viral infections. Going back 20 or so years, there's a series of really interesting studies in mice looking at the role of selenium deficiency. These are quite important in the context of coronavirus, I think. These studies were led by Melinda Beck. And what the studies, I remind you, these are in mice. What they showed is that infection of viruses in selenium deficient mice creates poorer outcomes than infections in selenium replete mice. So selenium deficient mice were, the virus was more infectious. Actually, the virus mutated in the selenium deficient state. And this was a range of different viruses, including Coxsackie virus. And in this paper in 1995, the conclusion was that a specific nutrient deficiency, that is selenium deficiency, caused changes in the viral genome, permitting a stronger virus to become, permitted a weak virus to become a strong virus as a result of those mutations. They went on to look at the effect of selenium deficiency on influenza virus, virulence and mutations. And again, they showed the same thing, that selenium deficient mice infected with a normally mild strain of the flu virus actually were more severely affected compared to selenium adequate mice. Immune function was altered in the selenium deficient mice, and the viral genome was mutated to become more virulent. So what about human studies? So this is a trial done in the UK, published in American Journal of Clinical Nutrition in 2004, where they took adults with low selenium status, put them into a trial where they gave them either 50 or 100 micrograms of selenium per day. And during the course of that trial, they gave these volunteers polio vaccination. So this is T cell proliferation at baseline. This is interferon gamma production at baseline. And then this is following polio virus vaccination. So the individuals who received the selenium in the study showed better T cell function at 7 days, and they showed greater interferon gamma production at 7 and 14 days than those in the control group. So these are important aspects of antiviral immunity, as I mentioned before. They also looked at the shedding of poliovirus in the feces of these individuals at 7, 14, and 21 days. And what they found was the number of subjects shedding poliovirus was decreased at 7, 14, and 19 days in a selenium dose-dependent way, indicating that those individuals who received selenium were better able to deal with the virus and destroy the virus compared to those in the placebo group. And then intriguingly, these are the polioviral gene sequences showing genetic variants cropped up in those in the placebo group, but in those who were receiving 100 micrograms of selenium per day, those genetic variants didn't occur. So this is a human study which replicates what Beck had seen in animal studies, that viruses can become mutated and more dangerous in selenium deficient states, and that giving selenium can create a better immune response and can decrease the likelihood that the virus will mutate, meaning it's probably not becoming more virulent. Interestingly, just last Thursday, this paper was published online in American Journal of Clinical Nutrition. In this study, the researchers relate the cure rate to coronavirus versus the reported city population selenium status based upon hair selenium levels. And essentially what they're presenting is an association between the ability to cure Chinese patients from COVID-19. In other words, this is the reverse of survival, compared to the average selenium status in that particular city. So these are data across several cities within China. And essentially, they showed this positive relationship. So this is an association between higher selenium status and ability to deal with COVID-19 in China, which is pretty interesting. So the last aspect I want to talk about briefly is the microbiota and immunity. So as you know, the gut is colonized by organisms, particularly the colon or large bowel has a very high colonization, perhaps a million organisms per gram of contents. And this is believed to be very important in educating and controlling the host immune response. And that's because the organisms in the gut lumen out here are interacting not just with the gut epithelium, but are interacting with the host immune system to optimize immune responses. So an adverse gut microbiome called dysbiosis results in a less than optimal immune response. So getting the gut microbiome right is also important in supporting the immune system. And of course, many factors affect the gut microbiome, including diet. So it's interesting, this paper from a couple of months ago from Chinese researchers commented that patients with COVID-19 have intestinal microbial dysbiosis with decreased amounts of lactobacilli and bifidobacteria. And it turns out, of course, that lactobacilli and bifidobacteria are amongst the most important probiotic organisms that control dysbiosis and help support the immune system. So this is the recently released handbook of COVID-19 prevention and treatment from the Chinese authorities. And there's a whole section here where this handbook talks about the dysbiosis in these patients and makes a suggestion that gut microbiome should be measured in COVID-19 infected COVID-19 patients, and that maybe probiotics are a treatment for this dysbiosis, and that might be important. So there's a whole range of micronutrients that I've touched on. I talked specifically about a couple of these, and I mentioned the microbiome. These are important to support the immune response, and also most of them have been shown to be important in reducing incidence and severity of infections, including respiratory infections. So if we look at dietary sources of those nutrients, we find, of course, all sorts of things, but many fruits, vegetables, pulses, nuts, seeds, oily fish, some animal products like milk, some meat for some nutrients like iron, vitamin B12 are important. But if we put all of this together, we actually come up with an immune supporting diet, which is exactly the same as a healthy, diverse, well-balanced diet with lots of plant-based foods, fruits, vegetables, berries, nuts, seeds, pulses, some animal-based foods to provide particular nutrients like oily fish for omega-3, meat for vitamin B12. So this sort of diet provides the nutrients required by the immune system to function well. And coincidentally, of course, this diet will also create a healthy gut microbiome. So in summary, the immune system is central to protection against infection. It's complex, but there are specific ways in which the immune system deals with bacteria and deals with viruses. I didn't mention this, but immune function declines with aging. It is also impacted by obesity. Multiple nutrients, including a range of vitamins and trace elements, play important roles in supporting the immune system, and low intakes and status of these impair immune responses, making people more susceptible to infections, including viral infections. It's known in human settings that this adverse situation can be prevented or reversed by nutrient repletion. Zinc has special roles in antiviral immunity. I think that's pretty interesting. And this role of selenium in controlling viral mutation is also very intriguing. The last thing I mentioned was the gut microbiota plays a role in determining the immune response. The microbiota also changes with age, with obesity, and with poor nutrition. And importantly, gut dysbiosis has been described in patients with COVID-19. So my conclusions are here. Nothing people can eat will stop them getting infected with coronavirus. Good immune defense is vital to combating infections, including with coronavirus. A range of nutrients have multiple roles in supporting the immune system to function, and inadequate intakes impair immunity. Gut microbiota has an important role. A healthy, diverse, well-balanced diet will provide the nutrients required by the immune system to function well and will create a healthy microbiota. And I think that advice should be reinforced at the current time. But it's also important to note that human experiments investigating micronutrients like zinc or vitamin D or selenium or any of the others, so human experiments investigating micronutrient immunity infection often use intakes above those recommended. And in many cases, supplements would be required to achieve those intakes because it would be hard to get those levels of intake from the diet. So thanks very much for your attention. I hope that was interesting, and now we can hear more about vitamin D.
Thank you very much, Philip. It was very clear, interesting presentation. We already start receiving questions. Let's move to our next speaker before we open the panel discussion. So Professor Adrian Martineau is Professor of Respiratory Infection and Immunity at Queen's Mary University of London in the UK. He is a respiratory physician with a research interest in the effect of vitamin D on human health. His work combines laboratory investigations, clinical trials, and meta-analysis investigating the potential for vitamin D supplementation to prevent and treat respiratory disease. His research is funded by the UK Medical Research Council, the UK National Institute for Health Research, and the National Institute of Health in the US. So, Professor Martineau, the screen is yours.
Well, thank you very much for the introduction, Stefan, and thanks also to Philip for a really comprehensive overview, global overview of the effect of different micronutrients on antiviral immunity. By comparison, my talk is rather narrowly focused. I have a degree of tunnel vision when it comes to micronutrients, but I hope to share some new results of unpublished data looking at the effect of vitamin D on susceptibility to acute respiratory infections. So the idea that vitamin D might augment host response to respiratory pathogens is an old idea, and it perhaps goes back to the 19th century when it was common practice for patients with tuberculosis to be exposed to ultraviolet rays from the sun in order to boost their vitamin D status and improve recovery. In fact, I'm actually sitting in a tuberculosis clinic now where we give vitamin D to our patients. But tuberculosis causes a bacterial infection, and if we look at viral infections as well, which typically cause upper respiratory infections, we can see that there's an inverse association when you look at ecological data between circulating 25-hydroxyvitamin D concentrations in the population and risk of viral respiratory infections, this study done in the UK population. Now, of course, this may be confounded by season, but when you stratify the data by season and then look at risk of recent upper respiratory infection by vitamin D status within each season, you can see that with these observational data, the risk of recent infection is highest in those with the lowest 25-hydroxyvitamin D level. When it comes to pneumonia, again, there are observational data suggesting that vitamin D deficiency associates with increased susceptibility to pneumonia. These data from children under 5 years, but there are plentiful data in adults as well. But of course, the infection that's on everybody's mind at the moment is COVID-19. And just again, looking ecologically, if we draw a line where the equator is, you can see that a large amount of the burden of disease and mortality has been focused on the Northern Hemisphere. There are potentially many reasons for this, but one potential contributor could be that the outbreak occurred towards the end of winter, beginning of spring, when Northern Hemisphere vitamin D status is at its lowest. By comparison, outbreaks in the Southern Hemisphere have not been so severe, and in those countries, vitamin D status is currently at its peak. Again, I had a caution that there are numerous public health interventions that have differed between North and South Hemisphere that could also have contributed to this observed pattern. There's starting now to become a trickle of studies that have looked at vitamin D status in patients infected with coronavirus. Here's one of them, a study by Mark Alipio, looking and comparing clinical outcomes in patients who have had coronavirus 2019 disease and showing that the prognosis, poor prognosis and adverse outcome associates with a higher risk of vitamin D deficiency. It should be noted, of course, that these again are observational data, so it may be that the association is explained by confounding or by reverse causality as much as by forward causality. So in the talk I'm about to give, I just want to give you a feel for the global burden of acute respiratory infections, of which COVID-19 is an example. Discuss how vitamin D modulates the host response, particularly to respiratory viruses. And then I want to really review clinical trial evidence, because there are now over 40 randomized controlled trials looking at the question of whether or not vitamin D might reduce risk of acute respiratory infections. And then discuss some research approaches to looking at the role of vitamin D in the current outbreak. So before I go on to quantitate the global burden of acute respiratory infection, I just want to highlight what I mean when I use the term. And by it, I mean infections of the respiratory tract with symptoms lasting up to 30 days. And classically, these can be categorized more or less successfully by looking at upper respiratory infections, where symptoms and signs are confined above the vocal cords, and those lower respiratory infections where the symptoms and signs are confined below the vocal cords. And COVID-19 is one of many examples where it's very difficult actually to draw the line and dissect out these two clinical entities, because it's well recognized, of course, that SARS-CoV-2 can cause disease and pathology both above and below the vocal cords. In terms of the global burden of acute respiratory infection, upper respiratory infections are the commonest infectious disease of humans. They have a major economic impact, but classically until now have caused very little in the way of mortality. By contrast, lower respiratory infections, such as acute pneumonia, are responsible for 2.8 million deaths per year, with young children and older adults, particularly in low-income countries, affected. To put those numbers in context, so far COVID-19 has been responsible for an estimated 3.5 million cases. That's just tested people. Of course, there are going to be many more cases that haven't had testing, with around 250,000 deaths so far globally. I mention here asthma and chronic obstructive pulmonary disease, not because these conditions that are caused by respiratory infection, but because morbidity and mortality in these two conditions is precipitated most commonly by viral respiratory infections, which precipitate acute exacerbations, which account for mortality due to these conditions. So how does vitamin D modulate the host response to infections? Let me just refresh your memories on vitamin D metabolism. Of course, it's best known as the sunshine vitamin, and that's because ultraviolet B in sunshine catalyzes the conversion of 7-dehydrocholesterol here on the top left of the screen to vitamin D3 in the skin. Vitamin D3 can also be obtained from the diet in the form of oily fish, and indeed vitamin D2 can be obtained by ingesting plants and fungi which contain ergocalciferol. The vitamin D from either source is hydroxylated by the liver primarily to form the major circulating metabolite 25-hydroxy-vitamin D, or calcidiol. This is what one measures when one measures somebody's vitamin D status. And then that major circulating metabolite is then further hydroxylated at the 1-alpha carbon position to form 1,25-dihydroxy-vitamin D, also known as calcitriol, which is a steroid hormone and which has pleiotropic actions, both regulating calcium homeostasis, immune function, and many other biological functions. And the conversion of 25-hydroxy-D to 1,25-dihydroxy-D is catalyzed by this enzyme in red here, cytochrome P450-27B1, also known as the vitamin D 1-alpha hydroxylase. And this is expressed not only in kidney, where it regulates circulating concentrations of 1,25-dihydroxy-D, but also in a range of immune tissues and also in respiratory epithelial cells to make 1,25-dihydroxy-D in low concentrations, which can modulate paracrine and intracrine actions. So the best described pathogen with regard to effective vitamin D on the host response is Mycobacterium tuberculosis, here illustrated on the left. And Robert Modlin and colleagues in Science back in 2006 demonstrated that infection with M. tuberculosis upregulates expression of the enzyme which activates 25-hydroxy-D to form 1,25-D. This 1,25-D then supports induction of innate antimicrobial responses, including generation of reactive oxygen intermediates, reactive nitrogen intermediates, autophagy and antimicrobial peptides, which by diverse mechanisms can have direct antibacterial activity. Not only that, but also via different mechanisms, including inhibition of NF-kappa B pathways. 1,25-dihydroxy-D inhibits potentially immunopathological inflammatory responses. After this work was done on tuberculosis, interest started to increase in the effects of vitamin D on antiviral responses. It was shown simply that respiratory syncytial virus and other respiratory viruses had a similar property of being able to induce the machinery which activates 25-hydroxy-D to its active metabolite, to induce, in this case, antiviral responses, as well as attenuating harmful inflammatory responses. Let's talk a little bit more, though, about attenuation of inflammatory responses, because this is very important when it comes to consider pathology related to SARS-CoV-2 infection. And the reason this has attracted a lot of interest, particularly around vitamin D, relates to this enzyme here, ACE2, which stands for angiotensin converting enzyme 2. So what I've illustrated in this slide is a pathway called the renin-angiotensin axis. And let me just walk you through it, because it plays a critical role in regulating inflammation in the context of COVID-19. So angiotensinogen is synthesized by the liver and converted by renin produced in the kidney to form angiotensin 1. This angiotensin 1 is then further converted to form angiotensin 2 by an enzyme called ACE, angiotensin converting enzyme, which is expressed primarily in the lungs. Angiotensin 2 then ligates the AT1R receptor here to initiate a program of physiological actions which essentially comprise pro-inflammation, vasoconstriction, and thrombosis. And certainly excess and pathological inflammation and thrombosis are very common features of COVID-19 clinically, and they associate with adverse outcome. However, all is not lost, because ACE2 is here on the horizon to attenuate angiotensin 2 mediated pro-inflammatory action. So, and it does this by basically taking angiotensin 2 and converting it to a metabolite, angiotensin 1-7 here, which will ligate a separate receptor, MAS receptor, to counteract the effects of angiotensin 2 on AT1R by regulating inflammatory responses. So you have a sort of a yin and yang situation here, whereas angiotensin 2 is the bad cop, if you like, responsible for supporting immunopathological inflammation, with ACE2 taking it away to make angiotensin 1-7, which then regulates inflammation and dampens down immunopathology. So what does this have to do with vitamin D? Well, ACE2 is key. And there's a conundrum really that has arisen relating to the relationship between ACE2, the coronavirus responsible for COVID-19, and vitamin D. And let me just summarize that for you, because it's a cause of a great deal of debate and not a little confusion. So ACE2 is important in the context of COVID-19 because membrane-bound enzyme is the entry receptor, or major entry receptor, for the virus responsible for COVID-19. Not only that, but when the virus infects the respiratory epithelial cell, one of the first things it does is to downregulate ACE2 expression. We know that, as I've just explained, overactivation of the renin-angiotensin system, in other words, a high ratio of ACE to ACE2 activity, associates with poor prognosis in COVID-19 due to dysregulated inflammation and a prothrombotic state. But where vitamin D comes into this picture is that it increases expression of ACE2, and in a rat model, it's been shown to attenuate lipopolysaccharide-induced acute lung injury. Let me just put that on the cartoon I had previously. So here's coronavirus, and you can see that positive arrow there indicates that it's entering the cell via membrane-bound ACE2. Let me now illustrate the principle that once the cell is infected, that reduces cell surface ACE2 expression. The effect of the coronavirus, therefore, on reducing ACE2 increases the ACE to ACE2 ratio and results in a high degree of inflammation, thrombosis, and poor prognosis. Bring 1,25-dihydroxy-D into the equation, and you then potentially can increase back expression of ACE2. Now, in one respect, some people have argued this might be a bad thing, because if you've got more ACE2 expression on the cell surface membrane, then that will increase the number of molecules to which coronavirus can bind and potentially increase its ability to enter the cell. But on the other hand, it will restore balance between ACE2 and ACE1 and potentially antagonize the effect of angiotensin to regulate inflammation and therefore cause a better clinical outcome. And the observational data which I showed you previously associating higher vitamin D status with better prognosis in the context of COVID-19 are consistent with this idea that the net overall effect of vitamin D will be to regulate immunopathology. I've gone into that rather involved discussion, which is based on a large amount of in vitro models and animal studies. Let me step back a moment and actually look at what happens when you give vitamin D to people. So, as I mentioned at the start of the talk, a number of randomized controlled trials have been conducted to date showing investigating the effects of vitamin D on risk of acute respiratory infections. 25 of them we included in recent meta-analysis, and their geographical location is illustrated on this map. They were all double-blind, randomized, placebo-controlled studies, representing females and males equally, and looking at oral vitamin D3 at various frequencies. And here's the forest plot. Two things to note. First of all, overall, there was a modest protective effect of vitamin D supplementation. But secondly, the I-squared statistic here on the bottom left of 53.3% indicates there's a high degree of heterogeneity. To put it in another way, vitamin D works sometimes, but not others. So we tried to then consider why vitamin D might work in some people and not others. And we followed the words of Einstein here, who said that a scientific theory should be as simple as possible, but no simpler. In other words, one could say that it's unlikely that somebody with low vitamin D status at baseline is going to respond in the same way somebody who already has higher vitamin D status at baseline. So instead of doing aggregate data meta-analysis in which one is unable to dissect out people with different vitamin D status at baseline, we took an approach using individual participant data, so the raw data from clinical trials, and we hypothesized that vitamin D would be most protective in people with the lowest vitamin D status at baseline. Here are the data from that meta-analysis, and indeed what we see is that when you look at people with the lowest 25-hydroxy-D level, you see a strong protective effect of supplementation, whereas when you look at those with higher status, there's no statistically significant effect. And this p-value for interaction simply indicates that the effect of vitamin D is different in those who have low versus high baseline status to start with. Okay, so it looks like from the RCT data that for a generic acute respiratory infection outcome, vitamin D works best for protection when it's given to those with the lowest baseline status. And we should really have stopped there. But wanting to test this in a rigorous way, we then went on to do a phase 3 trial in a population where vitamin D status was extremely low. And these are unpublished data soon to come out in the New England Journal of Medicine. We did a study in Mongolia because there's very low vitamin D status there due to the harsh winters, air pollution, and low dietary vitamin D. For this trial, funded by National Institutes of Health, we randomized just over 8,500 primary school children to receive a weekly dose of 14,000 units of vitamin D versus placebo for a period of 3 years. And we compared their incidence of acute respiratory infection between arms. And I just want to acknowledge here the absolutely critical input of Dr. Ganmar Davasambu, who is from Harvard School of Public Health and the Mongolian National University of Medical Sciences. So here's the consort diagram, but in a nutshell, we randomized about 4,500 children to each arm, and follow-up was 92%. Again, I'm conscious that time is ticking on, so let me just highlight that 95% of children had low vitamin D status, less than 50 nanomoles per litre, or 20 nanograms per mil, and that the intervention was effective in correcting vitamin D status. Despite this, however, we found no effect on self-reported acute respiratory infections, either in the population overall or in those with the profoundest vitamin D deficiency. When we looked at antibiotic use, again, we saw no statistically significant effect. And when we looked at hospitalization, again, there was no statistically significant effect. So the bottom line was that in this very deficient population, tripling vitamin D levels was safe, but it had no effect on the risk of acute respiratory infection. Why didn't it work? Well, hypotheses that we're considering are that we were perhaps too generous with the vitamin D, that perhaps some of the regulatory immunomodulatory actions at this higher dose outweighed the positive effects on innate immunity. perhaps weekly dosing is not as good as daily, or perhaps the positive results from the meta-analysis can be attributed to publication bias, in that the smaller studies tended to be show protection, whereas the large studies tended to be null. In terms of future directions, we're going to rerun this meta-analysis with the additional 15 trials and another 20,000 participants that have emerged since our first run. Just to give you a flavour for what's going to look like, we have all but 2 now here, and we're still seeing an overall protective effect, although there's still a fair degree of heterogeneity. In other work, we've established a population cohort called COVID-19 in the UK. It's going to recruit 12,000 people, and this will act as a platform where we can evaluate the effects of interventions, including micronutrient supplementation, for prevention of COVID-19 and reduction of pathology. So if you want to find out more, anybody in the UK age 16 plus who lives in the UK can take part in this study, and I draw your attention to the web link below, qmul/COVID-19. And that is the end of the talk. So thank you for your attention.
Thank you very much to both our speakers. We received many messages to thank you for the quality and the clarity of your presentation. So let's start now with our questions. Well, maybe the first one is, there's a strong and harmonized message from national and international public health authorities regarding the importance of social distancing, washing hands, and so on, advice we provided at the beginning of this talk. But at the same time, the message regarding the importance of nutrition does not come across very clearly in the media, for example. So how would you explain that, seeing how important nutrition is?
Yeah, maybe I could start the discussion on that, Stefan. So I've noticed this myself. Now, one of the interesting things is here in the UK, right from the start of what we call the lockdown, the work at home period, the government has emphasized the importance of physical activity. And despite the lockdown in the UK, people are allowed out daily for physical activity, and many people are taking advantage of that to walk, to jog, to cycle, to do all sorts of things. So the government has really emphasized the need for people to remain physically fit, probably for general good health. What has been missing from this, so, you know, I support that message, of course, but what has been missing in all of this messaging is the importance of a healthy diet. And I don't fully understand why that is missing. I know that in some places people have tried to get that more strongly on the agenda, but it hasn't been really emphasized. In the UK, again, the NHS, Public Health England, they have information on their websites right now about healthy eating, but we don't, for example, see advertisements on TV the way we see advertisements for other aspects of lifestyle. So your question highlights something which I think is really important, and for which actually there isn't a clear explanation.
Thank you. Anything you want to add, Adrian?
Yes, I think a second factor that's worthy of discussion is the fact that the evidence base from randomized trials for prevention of COVID-19 is, of course, lacking, because we've not had COVID-19 around long enough to do any trials. But I think there is a philosophy around the UK government, certainly, that there's a great reluctance to recommend things which aren't of proven benefit. I think, speaking as a respiratory physician, that's very much reflected in clinical practice in the treatment of COVID. So there's been a strong drive not to try any experimental drugs, but to push everyone through into randomized controlled trials. And I fully support that initiative. But I wonder if that same ethos has also influenced thinking with regards to making dietary recommendations to the whole population
Yeah.
Maybe
Yeah.
that people are just saying you don't have the positive, you don't have RCT evidence here, so until that's there, we're not going to make any pronouncement on it.
Yeah, I think, Adrian, that's a really good point. So if you said, if someone went to the Minister of Health and said, why aren't you recommending healthy eating? And he said, oh, is there evidence that healthy eating protects against coronavirus or COVID-19? Then the answer would have to be no, there isn't. So he would say, well, there's nothing to say then. So I think, my talk is extrapolating from other types of science, not coronavirus. So I think that I think is, you're right, that there's that sort of mismatch between the actual evidence and the desire for advice. But of course, there's never any harm in recommending healthy eating anyway. So I think that's the sort of the conundrum I have.
Okay, thank you very much, both of you. So maybe for you, Adrian, mentioned that low level of vitamin D can have adverse outcome of viral infection. But what if you start getting the disease and then you start supplementing with vitamin D? Can it change something, or is it already too late?
Well, the short answer to that is it's not known because the RCTs haven't been done. I understand that there are 2 RCTs ongoing in Europe, one in Nantes in France, the other in Gibraltar, in which vitamin D, adjunctive vitamin D, is being administered, or placebo, to people who are presenting to hospital with COVID-19. So it will be interesting to see the results of those trials as and when they emerge. My only the best RCT experience of giving vitamin D to people who are already ill comes from the context of pulmonary TB, and in that context, we've shown that giving a high dose of vitamin D can have anti-inflammatory activity, but this isn't really associated with major improvements in clinical outcome. However, this is in the context of an infection for which there's already effective antimicrobial therapy. Obviously, we're not in that situation with COVID, so it could well be that having an anti-inflammatory, particularly one that's not immunosuppressive in the way that corticosteroids are, could confer a benefit. So I'm looking out for the results of those RCTs with a lot of interest.
Okay, thank you very much. Philip, you mentioned that the immune function declines with aging. And so the question is, how can we either delay this decline, or how can we overcome it?
Yeah, so as in many bodily systems, the immune system stops working quite as well as people age. So that's a process called immunosenescence. And there are many things that are factors involved in immunosenescence. 2 of them are, firstly, that all immune cells originate in bone marrow, and there seems to be decreased output of immune cells from bone marrow as people age. Secondly, T lymphocytes mature in the thymus, and the thymus is well known to get smaller and less cellular as people age. So there's decreased output of new T lymphocytes. So in other words, the immune cell numbers change in the blood of older people. They accumulate what are called memory cells, and they don't have so many new cells that can deal with new pathogenic insults. The function of cells declines, and so on. Aging, again, paradoxically, is often associated with increased inflammation. So there's an imbalance going on. Now, what is known is older people who are better nourished, particularly micronutrient nourished, actually have less signs of this immunosenescence. So it may be, again, that nutrition is one of the factors that can slow immune decline, just like nutrition is important in slowing other structural and functional declines, for example, muscle loss, bone loss, maybe even cognitive loss. So I think nutrition can be part of the picture. Probably if you looked at my earlier slide with the many factors influencing the immune response, many of those factors will be quite important. Gut microbiota may play a role, physical activity may play a role. So I think it's probably a general healthy life is important to combating immune decline with aging.
Okay, and maybe another question that I think is interesting is, do mothers who are infected with COVID-19 will likely develop better immunocomponent in the breast milk? Do you have any study on that or any?
I think that is a great question, because of course one of the advantages of breastfeeding is the passing on to the nursing infant of antibodies and other immune factors. And I think, I mean, Adrian can come in after me and maybe say a bit more, but it's well described, at least for some infections, that immunity can be passed through breast milk. I doubt, well, certainly I haven't seen anything on coronavirus and breast milk. I doubt there's much out there, but maybe Adrian can give more of a clinical perspective on the passing of immunity from mother to suckling infant.
Yes, I mean, I think you've pretty much captured it, Philip. The only slight detail I can add is that this is primarily immunoglobulin A, so it particularly relates to mucosal immunity, which is going to be important in the context of COVID-19, of course.
Yeah, I think it's a great question, though.
Okay. And also we got a lot of questions regarding autoimmune patients or even people. So how should they deal with it during this critical time? What would be your advice?
Well, happy to
I'll
chip
let
in here.
Adrian go first. Yeah.
Yeah. So I think I would really take people back to one of Philip's very early slides, where he says that nutrition isn't going to stop you getting infected. It's really only going to attenuate potentially the clinical course of the disease. So for people with immunosuppression, they really want to have the lowest risk of getting infected possible, and so it's measures such as not avoiding social mixing, washing hands, etc., that are going to be the critical ones. There's really no firm evidence around nutrition that will say that that's going to stop you getting infected.
Yeah, okay. Philip, do you know if there's already any trial studying omega-3 fatty acids in COVID-19 patients? And do we have any results?
So I didn't, unfortunately, there's many things that I could have talked about, and I didn't talk about omega-3s because I think what's clear is the data on the classic micronutrients is much clearer than the data on some of the other things like the amino acids, the fatty acids. I think the really important role of omega-3s is in controlling inflammation and stopping adverse inflammatory responses. And in severe patients who need ventilation, you know, part of the pathology, as Adrian mentioned, is actually driven by the host inflammatory response to the viral infection. And that becomes very damaging. And of course, you then get transfer, if you like, to other organs, and ultimately you can have serial multiple organ failure. And data in acute respiratory distress syndrome, but not related to coronavirus, does indicate that there are nutritional strategies that can reduce the impact of this hyperinflammation in respiratory distress syndrome. And there are trials of very high doses of omega-3s in either enterally or intravenously in acute respiratory distress syndrome that show benefits. There are also, interestingly, there are trials of infusion of vitamin C in sepsis and in ARDS. And I know there is a trial, I think, in the US of intravenous vitamin C going to be done in COVID-19. I haven't heard of any omega-3 trials but I have heard one or two people talk about whether that is sort of a rational thing to try at this stage. I think one of the, and Adrian alluded to this, one of the difficulties is this virus and its disease have happened really quickly and is quite uncharted waters, and therefore people are putting a lot of thought into what sorts of trials could and should be done, because it's rather unknown, and jumping from one disease to another doesn't always make 100% sense. So I think maybe there's a bit of conservatism perhaps in terms of thinking what could we do, because a trial needs to be really have a robust hypothesis before you do it. I actually have an article which has been accepted for publication, which includes a lot of the stuff in my presentation, where I do talk about omega-3s in severe COVID-19 and the possibility. But the answer to the question is I'm not aware of people doing those trials right now.
Okay, thank you very much. Adrian, we get questions regarding the last study you present, and the question is, in the Mongolian population, is it possible that a compensatory mechanism has developed because of chronic vitamin D deficiency? Is it something you looked at?
Yes, this is an excellent question, and it was one of the fourth possibility that we explored to try and explain why we had such strikingly null results. And to explore it, we basically measured parathyroid hormone and alkaline phosphatase concentrations in a randomly selected subset of the children. And we hypothesized that if this was a population that had inherently lower vitamin D requirement, then supplementation would not suppress secondary hyperparathyroidism or ALK phos levels. But in fact, what we saw was that commensurate with the very high prevalence of low vitamin D status, there was a lot of secondary hyperparathyroidism, and our supplementation was effective in suppressing that. So I'm not particularly persuaded that the Mongolian population is somehow systematically different in its response to vitamin D as compared with other populations where trial results have been positive.
Okay, and maybe a follow-up question. You asked whether the air pollution in the country where you conducted the study may have also an impact on aggravating maybe virus-induced respiratory disease. Is it also something you've looked at?
Yes, so there's good evidence that air pollution increases risk of acute respiratory infections. And there's also evidence from in vitro studies, actually, that vitamin D can attenuate the pro-inflammatory effects of inhaling particulate matter on the lung. We were only able to get ecological pollution data, so it wasn't really as granular as we liked. But in the coarse analyses that we didn't find any difference of effect of the vitamin D in parts of the city where pollution was higher than others.
Okay, thank you very much. Philip, a question coming from Asia. It says that there are specific phytochemicals in vegetables, such as quercetin and camphorol, that are shown to enhance immunity. However, consumption of vegetables are generally low in some countries or regions. Is there a link between low consumption of vegetables and COVID-19 infection or recovery? Do you have any idea?
Yeah, I think this is a good question. So you know, my central thesis is the best diet to support the immune system is a diet which contains a diverse array of fruits, vegetables, and other plant-based plant foods, along with some fish and animal foods. So the reverse of that would be that a poor diet would be, for helping the immune system, would be one which is low in those things and high in processed foods that don't deliver the mainly plant-derived nutrients and chemicals. So your questioner is correct that many of the plant phenolics have been demonstrated to play a role in the immune system, mainly probably in vitro and animal studies, although there are some human studies in this area. So I think I wouldn't want to say not eating vegetables is a predisposing factor for coronavirus severity or COVID-19, or that not eating specific fruits or vegetables. But it could be, you know, poor diet could be a factor, along with some other factors which coincide to mean that an individual does worse if they happen to be infected. So, for example, obese people seem to do worse, older people do worse. So if you had an individual who was, you know, perhaps overweight, had a poor diet, wasn't physically fit, they may not do very well compared to someone who was also a bit overweight but had a good diet and was physically fit. And I think other respiratory infections would support that sort of thing. So I think, you know, diet is part of the protective environment, if you like, and I wouldn't want to finger out, you know, a specific food or a specific type of diet anywhere as being the answer, but it would be part of the mix. And again, I think data will come out over time from these patients where we can pick out all the different things that people are interested in, the dietary patterns, the nutrient exposures, you know, body mass index, all of these things will come out in time when people are looking at the databases. But at the moment, actually, I haven't seen very much on diet and COVID-19. I know Adrian has been very interested in this, and he talked about his trial at the end. What he's seen, apart from obesity, whether there are any particular dietary elements that have come out in the literature, I haven't really seen anything.
Yes, so maybe to follow up with that, because I think it's totally in line, the question from someone else is, based on the data you presented on the association of obesity and immune function, would you recommend different nutrition guidelines, for example, regarding quantity of micronutrients, specifically for the obese population?
Yeah, I think that's a great question. So I think, you know, in the long term, I would recommend that people should try to limit their weight to you know, the limits that are generally regarded as healthy. But, you know, that's a long-term strategy which all governments have. What the question is about really is in an acute setting, could an obese person protect themselves through a better diet? And I think my gut response is I think it would be, I think an obese person who tried to limit their energy intake, but at the same time ate a healthier diet, would be in better shape. Now the question asks, you know, maybe should the nutrient recommendations be different for obese and non-obese people? I think that's a sort of one would need to consider that in a bit of detail, and I don't at the moment sitting here have the time to fully think it through. We know, of course, that other groups, other subgroups in the population do have different dietary recommendations. For example, you know, there are different recommendations in pregnant and non-pregnant women for some micronutrients. People who take a lot of exercise have different dietary requirements than people who have less exercise. Older people are different from younger people, and there are different recommendations. So I think it's an interesting question. I think by giving different recommendations to obese compared to normal weight people, you're recognizing, you would be recognizing that obesity was a different but normal physiological state. And I don't think any governments or regulatory authorities would want to do that. However, of course, there are diseases where people have different dietary requirements and there are different recommendations. So I think it's a really interesting question. I don't actually know the answer, but it's got me thinking. So thanks.
And maybe now a question for Adrian related to, I guess, vitamin D, sun, lockdown. So we get this question, which it says that from infection in south of the Ecuador is very low as compared maybe to the northern hemisphere. So can you speak a little bit of potential effect of the lockdown somehow and people not going out, not being exposed to the sun?
Yes, so I think to reiterate the point about the drivers of infection as opposed to the drivers of poor outcome, I think the drivers of infection are public health policy. And one only has to compare what was done, for example, in New Zealand or South Africa to what wasn't done in Britain, Italy and Spain. And one can draw some fairly simple conclusions about what public health action is effective and what happens when one dithers. In terms of population effects on nutrition, or nutritional effects or other lifestyle effects on outcome, I think the metric for that would be either effectively the case fatality rate. So one might imagine, take for example a hypothesis that's having a high vitamin D level might attenuate the course of the illness. One might see the same number of infections if one tested for them, but fewer of them would present to healthcare and fewer of them would be escalated to ventilation or progress to dying. So I think there are two different metrics here, and there are two different things affecting them. There's the incidence of infection, which is affected by public health measures, and there's the outcome of infection, which is potentially affected by all of the risk factors we've been discussing.
Okay, thank you very much. So maybe now my last question, and maybe I think it's a very important one, is for both of you, if you can take 2 minutes to answer. What action can be pursued by ILSI or other research organization to increase the number and quality of research in the area? So we know there's a lot of study going on. We know there will be a lot of data, but what do you foresee as maybe key steps in the near future to really improve the knowledge we have on COVID-19, the importance of nutrition? Philip?
I'll start if you like. I can start. So I think all hospitals will be gathering quite a lot of data on the patients they're caring for. And this will create, at least in some places, significant databases. They are the basis for publications which are already coming out, mainly from China, but also from other countries. For example, there's one, I think, on 5,000 patients in New York that's been published. So there'll be big databases that might capture some important things. What won't be captured in many of these, I think, are some of the normal what I would call nutritional parameters that might be important for me to investigate hypotheses I might have. So I think understanding the nature of the databases and then formulating rational hypotheses has to be the key. At the moment, most of the papers that are coming out in the area I would call are sort of a bit random. You know, there are observations that are being made, but of course this condition is only 2 or 3 months old. So down the line, I think people will be looking for more rational hypotheses and then searching the databases to answer those hypotheses. But you know, Adrian would pose the hypothesis that vitamin D status is relevant. You know, people might want to know about gut microbiome, for example. I doubt that information will be available, but those are the sorts of things.
Okay, thank you very much. Adrian?
Adrian's probably already got his list of studies ready to go. I don't know.
Well, I think the observational studies are really they're going to be really important because they're going to give us a quick a quick answer to questions whether or not nutrition associates with adverse outcome. I think there are two broad areas where there's not much activity at the moment and where there probably needs to be. One is in the community, so people who haven't presented to hospital, so looking at the aspect of prevention. And the second is clinical trials. And I think people I've spoken to have been quite nihilistic about the ability to do trials of interventions to prevent COVID as opposed to treatment trials. But I do think there's potential to do it. The reason I think it is because I'm afraid that COVID, certainly in places where it's escaped public health efforts to control it, is going to become, it's likely to become a chronic problem. So we are going to see hopefully a slow drip of cases. Hopefully it's not going to be a second wave. So there will be potential to intervene to see if we can prevent those. And I would, just in closing, draw people's attention to this concept of the trials within cohort idea. It's a way of combining longitudinal observational studies with intervention studies that's very inexpensive to do and very participant friendly, and that it avoids the need for placebos. Just going back to the original question, what ILSI can do, I think if we could get a coordinated international effort to set up several of these cohorts, there could be scope to pretty rapidly evaluate simple nutritional interventions to see if we can really attenuate disease while we're waiting for a vaccine, which is ultimately going to be a big part of the solution.
Okay. Well, I want to thank you again, both of you. Thank you very much for your time. Again, we see that the audience really appreciate it. We get a lot of message thanking you. I want to say that ILSI also has been pleased to organize this series of 2 webinars, and we've received a lot of feedback, and so we will do more. We're working already with the executive director of our entities to propose you a program of upcoming webinars. So stay tuned, follow our newsletter, and you'll hear more about us. So again, thank you very much, everyone, and have a good day or night. Bye-bye.